Good afternoon, everyone. Today we're going to find the derivative of a function f of x being called x squared plus 3x plus 2, basic quadratic function, right? Using the definition of the derivative, okay? So let's start by writing that out. So we have the limit as h approaches 0 of f of x plus h minus f of x all over h, right? As h approaches 0. So let's evaluate this limit for our specific function f of x. Now, f of x plus h means that everywhere that we see an x in the original function f of x, we replace every x with x plus h. So everywhere we see an x, here and here, we're going to replace the x with whatever we have in the bracket here, namely x plus h. So let's see how that works out. So we have x plus h all squared plus 3 bracket x plus h plus 2, right? Again, replacing the x with x plus h in brackets. And now we have all of that over h, right? Now we can work on expanding and simplifying the numerator. So sorry. Minus f of x, right? So minus, let's not forget, f of x, what we started off with, so minus that entire thing. Minus x squared plus 3x plus 2 in brackets, okay? F of x plus h minus f of x. Now, let's go ahead and let's multiply through the first part, expand so that we can group like terms. So x plus h all squared is going to give us x squared plus 2xh plus h squared, right? Then plus 3x plus 3h and plus 2, right? So that part is just f of x plus h expanded out. And now we still need to subtract f of x. So minus x squared minus each term, so minus 3x, and finally minus 2. And all this over h, right? Now we can work on simplifying down our numerator. So you'll recognize that the x squared here is going to cancel out with the x squared at the end. So those go away. Next, you'll recognize that 3x here is going to cancel out with the 3x at the end, right? From the minus f of x part. And the plus 2 is going to cancel out with the negative 2. So f of x cancels out a lot of the f of x plus h. Now what we have remaining, you might notice, all has an h part of it, right? We have 2xh plus h squared plus 3h. So let's go through the process of actually writing that out on its own. Because now you might notice that we can simplify something. Every term in our numerator has a factor of h at least, and so does our denominator. So we can cancel those out, right? We can simplify those down. And so the h on the bottom is going to cancel out the factor of h in the first term. It's going to factor out, it's going to rather cancel out the squared factor in the second term, and it'll cancel out the h factor in the third term. So now our limit simplifies right down to all we have left after the h's simplify themselves down is the limit as h goes to 0 of 2x plus h plus 3, right? After we subtracted all the terms and simplified down the h's through the numerator and denominator, this is all that we're left with inside of our limit. And now we want to evaluate this limit as h approaches 0. The only part of this expression that has an h in it is obviously the h term. And so as h goes to 0, that term naturally goes to 0. And so this term ends up being 2x plus 3. And that is our derivative, f prime of x. Okay? For those of you that have learned the power rule, you can probably differentiate this and get the same results to check your work. But if this is your first go with derivatives, this is how we do it. Hope that helps. Thanks for watching.